We live in a world of Ethernet frames, data packets going over the internet really, really fast at high speeds, and typically these protocols are going to be UDP and TCP. You can establish connections with servers and exchange data for your mobile apps, and this is typically REST APIs to fetch data, or you're getting streaming data from Netflix to get all the packets for the data, the image data, that's the video data. That is all over the internet, and these are Ethernet frames, and they are built in a way that allow us to exchange information between devices to do these sorts of things. And the starting point, the very beginning, is typically the same regardless of what protocol you're using from a TCP or UDP. Well, guess what? It kind of looks like this. Let's walk through a Python code. Every language is the same in regards to this fashion, whether you're doing the C and Java or Python or JavaScript. It's all going to be the same, very similar code. This is lower level. We're going to walk through what these things mean on the screen here, and we're going to use Python because it's, and actually, in some ways, C kind of looks similar. Though this is nice because it fits all into one screen. Let's take a quick look here. So let's start at the top. Python 3.7 plus. We're going to import socket. Now, socket is going to import some underlying kernel interfaces to bind on ports to accept incoming connections on a listener, and that listener is going to allow us to receive a request data from a client that we can then respond back with. So it's a read and write scenario. You'll do this kind of thing if you want to make your own custom web framework from scratch that can support HTTP or WebSockets or anything you want, MQTT, you can, or your own protocol. You can come up with any protocol you want. The internet is just a bunch of Ethernet frames, and you can stuff whatever you want in that data payload. And as long as those IP addresses match, the data is going to be routed. Those Ethernet frames will be routed to the right places with our routers. Let's walk through this. Okay, so we've got import socket. We're going to define a host and a port. Now our host is going to be empty. In this case, with an empty host, it's probably going to be localhost. It's going to be the system itself. You can either put 0.0.0.0 in for IPv4 or localhost as the string. 8080 or 8888 as the port is going to say what the port number is, and then now we've got two variables here. All right, we're going to create a listen socket. So we're going to instantiate a new socket. The AF INET is the address family, and this is going to be something that is mandatory. You can't live without this. This is going to be the communication pattern. Is it going to be IPv4 or IPv6? What happened to IPv5? Well, guess what? IPv5 is a dead protocol. Well, I guess it's still a protocol, so it's around. No one uses it. It was intended to be jumbo frames for large video packet streaming, which turns out you don't need it. You just don't need it. It's not something that's IPv6 came along and made some improvements on the packet. So you can use an address family, AF, for IPv4 or IPv6. And so in this case, it's IPv4. We're going to establish a streaming socket, which just basically says we're going to have data flowing back and forth bidirectionally. You can have additional sock ops, and in this case, it's going to tell the kernel how you want to buffer data, exchange data between the client. We're getting a lower level here with what's available in the kernel, and it's different on every operating system. And so in most parts, you just want to set a couple of sock options here. Reuse address is important because of port reservations and timeout and time waits. If you don't set this, it's possible that you'll exhaust your address table, and then even though you've closed the connection, a connection will actually remain open on the connections table in the operating system, and that if you don't have this option set, that table will fill up really quick, even though they will eventually go away after a minute or two, whatever's default for the operating system. You want to be able to reuse that list immediately because you can quickly exhaust your available ports. Then we will immediately bind the host and port, so an 8080 for localhost. Then we'll start listening, which allows us to accept incoming connections. We will print a message saying, okay, we're good to go. We are now available listening on port 8888 on this server, and now we enter the forever loop. The forever loop! And this will just loop and start listening for incoming connections. And so we will get the client connection and the client address through the accept method. We've got our listener socket that we've defined, and then we want to accept. So typically this line will block right here and hold until someone makes a request, an API call to our server, right? Well, essentially a connection request. So they'll send a connection request. This will populate the data on our variables, the connection itself, and a client address. Then we can start reading the data after we've established the connection with the client, and we want to read up to 1 kilobyte of data, 1024 bytes. And then we can print that data to our terminal window or our output, right? So we've created our server. We're waiting for data. This is actually kind of interesting. I bet we could try this out. We'll probably try this out here in a second. Then we'll print the request data. We'll make a response, ignoring everything that the client has sent to us. It doesn't matter what data you sent to us. We're just going to read the first kilobyte, print it out to our screen on our server, and then we're going to respond 200 OK. Hello world, no matter what you sent to us. Then we will send all of that data on the client connection here, which our client connection object we got, and then we're going to close the connection immediately. And that's it. That was a quick walkthrough of what a web server does when you make an API call to it using TCP, the internet, using the internet. That's what it looks like, and that's how it works on every single system. Let's start our own minimal HTTP web server. It's so minimal that it barely does anything related to HP other than just exchange text between a client and a server. I'm going to start a server on my laptop here that is running Python, and it's going to open a socket connection, accepting requests on port 8080 to localhost. Then we set the sock ops and we bind and we start listening. Then we accept a client connection. We get the client address, and we will wait for an incoming connection. We'll receive the first kilobyte. We'll print the response, or the request in that case, and then we'll provide a response in HTTP format. The client will send a response and close the connection. It's actually the minimal possible for HTTP server that you can have. Check this out. Okay, so on the left side of the screen, I've got my server. This is my server code right here. Very minimal. How many lines of code is this? Oh, 22. That's a pretty small HTTP server. So what I'm going to do is I'm going to start this server, and it is serving on port 8080 for localhost, which is my local system. Then I'm going to issue an API call to the my localhost using this request from this file. So a request data and essentially text data, right? And that's all we're looking at. So I'm going to send that request to the server, and then I should get back a response. Hello world, 200 OK. Let's actually give it a try, and then we'll play around. We'll play around with some of the formatting and see what we get from this. Okay, so I should be able to simply read the data from my request.txt file, which is up here, and then I will pipe that into a netcat, which is just going to open a TCP connection for me to my server, localhost port 8888. Okay, and then I should get back a response. Hello world, 200, and it works. And it was really fast too. So you can see that I got the response, HP 1.1 200 OK, which is right here from the server. Hello world, all looks good, and I can keep doing that because it's a server. It's just sitting there waiting for more requests to come in. It's actually kind of neat. And I could also print out the client IP. I'm actually kind of curious to see what the client address is in this case, right? So let's print out the address. There we go. And then restart our server, issue another request, and then I should see, yep, there we go, 127.0.0.1, which is loopback, which is your local host. Essentially, it's just your laptop talking to itself, or your server, or your desktop, whatever system, your phone even. You could do this on your phone too. And so I can keep making these API calls. And as you can see, oh, this is kind of interesting. As you'll notice, that I see a number here that's incrementing. And this is the client port. That is the port that's being used to communicate. So in the Ethernet frame world of the internet, there are a 5-tuple when you're communicating between devices. You need to be able to have an IP address for both the devices. So the client and server need to have their own IP addresses, and you need a port for the client and server as well. And this establishes my client port and the server port. Did you guess it? The server port? Yep, 8888, which that's my server port. And that is fixed typically. Whenever a client establishes a new connection, it generates a port based on the kernel of the operating system. It sort of manages the connection table for us using kernel APIs, and then it will assign us a port that we can fetch out to the internet, and this will be the response port, which means that you can have multiple connections to the same IP address with a different session, essentially, which allows us to do a whole bunch of things. You can have multiple connections and still receive data, and it will know exactly where to go. That number is really critical because it will assign it to a process ID on your computer. Whatever process is running that's waiting for that data can then get transferred back up to the application layer, so that way it can receive the data. In that case, it's my terminal window right here, and it will be able to show me the response from the server. Let's play around with this a little bit. Check this out. You can put whatever you want here. Okie, let's do okie dokie. I wonder if I could do. I wonder if I can do this. I'm pretty sure I can. Well, I mean, obviously, this is it. You can put whatever you want here. You can actually put whatever you want in any of this because I'm not using any HTTP parsers. This should still generally be valid. I'm not sure if the underscore is valid in this case. You can put whatever you want, though. That's just a status line, so it's okay. The 200, that has more meaning. It's more impactful. It says 200 okay. It is the response was successful, and expect data to come back as well. We can also play around. Obviously, I'm making an API call to my localhost, not to api.pubmed.com. You can put anything you want in here, and it should still work, even under the most strict of servers, depending on what the server is looking for. It's going to accept that pattern as well. So we can play around with this. We can do whatever you want. You've basically got your own server now with just this 23 lines of code, and you can do anything you want here. And all you have to do is parse the request. Maybe this line right here, right? So you've got the verb, and then you've got the path, and the path is the most critical aspect. And then you might want a payload section as well. And the payload section is going to be right here, so you can have your data. That's like data, right? All your data is there. Then we can make that. Okay, let me see our data being printed here. You can also, that's the payload area. So if you're going to do a post, it would look like that. And then you've got your data here. You've got your host, which is whatever you want. And you can make that API call. And it will do it for you. And as you can see, it's actually pretty flexible. Now you've got the power of the internet. This is the power of the internet. You've got your own server, and you can basically do whatever you want from it. This is the beginning. If you're building a business, it's like the very beginning. You're starting to build an API that you'll be able to sell to people.